Hello, how's it going today? Today, I would like to show you something interesting. I want to show you something called electric potential energy. So, we have gravitational potential energy, which is UG is negative G, which is a constant, M, big M, little m, over R. And what this is going to look like is you're going to look like big M and little m. And so UG is always going to be a scalar. What does that mean? Well, that means you simply are going to be adding these up. But you'll notice this negative. This means that electric potential, what I'm talking about right now, is gravitational potential energy. You'll notice that it's always negative, which means it's always attractive. You always do work against it. So this is force gravity. So you're always working against it. But for electricity, electric potential energy is K, which is a constant, Q1, Q2 over R. Now, K equals a constant of 1 over 4 pi epsilon naught. But this really just means K equals 9 times 10 to the 9 Newton meters squared per coulomb. Okay? UE is also scalar. However, it is dependent based upon the sign of the charge. So we have U, positive, and we have negative. That will yield a negative UE, whereas a positive and a positive will yield a positive UE. So you can see now how you want to put the signs in to solve for this. So plug signs into equation. That is one of the key things you need to remember about electric potential energy. You need to plug the signs into the equation. So now I'm going to do a few examples. So here's an example. We have 2 point charges. 2 point charges. We have 2 point charges of a Q1 of 4 microcoulombs and Q2, which is positive 6. Those are both positive. And we'll say R is 15 centimeters. So how are you going to find it? Well, you're going to do UE equals K Q1 Q2 divided by R. So this would be 9 times 10 to the 9 times 4 times 10 to the negative 6 coulombs times 6 times 10 to the negative 6 coulombs. divided by our radius, which is 15 times 10 to the negative 2 coulombs. Or meters. I'm sorry. I'm thinking the wrong unit. Okay? And your resultant for this scenario is going to be 1.44 times 10 to the 13 joules. Now we're going to look at it. What if Q2 were to equal negative 6 microcoulombs? Well, everything's the same. There would just be a different sign. So it would be negative 1.44 times 10 to the 13 joules. Now, here's where it gets tricky, okay? It gets tricky when a system contains more than 2. You might say, what do I do to solve it? Well, you're simply going to find that the U of the system equates to K times the summation of Q1, Q2 over R of 1 to 2. So that is how you would find U of a sys. Now, I was going to show you an example, but simply what you're going to do is you add up the individual Q's. So let's say we have this, 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 this. Now remember, it's a scalar. So we'll say this is positive Q. We'll say this is positive Q. We'll say this is negative 2Q. And we will say that this is also positive Q. And we will call this distance D. This is 2D, and this is just D. So that is what we'll call our distance. How would you find the U of the sys? Well, U of the system would be K times all of those individual interactions. So let me get out a different color for you just so I can show you the different interactions that were going to occur. So here's a different color. I got brown, okay? So there's one interaction from here to here. There's another one from here to here. There's another interaction from here to here. And another one here to here, here to here, and here to here. So now we're going to do that. This would give you, there is one interaction between two positive Q's. You see one here, one here. However, those D's are different. This is D, this is 2D. So you're going to write Q squared over this one, which is D, plus this to this, Q squared over 2D, plus, now we'll look at this. This is a positive to a negative, so that would be plus negative Q squared over D, plus, you will want to plus from here to here, which is negative Q squared over 2D. But we're not finished yet. We have these diagonals running from here to here. And you say, how do you solve that? Just use Pythagorean theorem. So D squared plus 4D squared will give you D squared plus 4D squared would give you 5D squared. And to find that triangle, you'd have root 5D. Okay? So you have a positive to a negative. So you do minus q squared, well, plus negative q squared divided by root 5 times d. And of course, plus q squared over root 5 times d. That is how you find U of a system. That is electric potential energy. This is something I thought people could use, people might find useful and exciting. And if you have questions, feel free to reach out in the comments. I'm available to answer questions and show you things, and I'm fine with that. So, once again, thank you